55. Find equations of both lines that are tangent to this curve but parallel to this. Okay, so we want, it says two of them. We want two lines that are tangent to this curve and parallel to this one. Well, parallel means same slope. And the slope of this is 12. If I add y and subtract 1, I have 12x minus 1. This is linear, has a slope of 12. Okay, now the derivative of this, dy dx, the derivative of that goes away, the derivative of that is 3x squared. Okay, so now I'm going to set these equal to each other because if they're parallel, they have the same slopes. So 3x squared equals 12. Divide off the 3. X squared equals 4. When you square root, x is equal to positive and negative 2. When you square root both sides, you have two of them. Okay, so they want the points where this tangent happens. Actually, they want the equations of the lines, right? Okay, so I have x now. X is positive 2. Well, if x is positive 2 and I substitute it back in, I have 2 cubed is 8, 8 plus 1 is 9. I have a point 2 comma 9. Okay, I also need a slope. Well, I'm going to use the same positive 2 in my derivative. 2 squared, well I don't, it's 12, right? But, okay, the slope is 12. I already knew that because it's parallel to this one. I could plug it back in. 2 squared is 4, 4 times 3 is 12, but I knew that already. Okay, let's go to the next one, negative 2. Negative 2 comma, that's negative 8 plus 1 is negative 7. And my slope is 12. So the equation of both lines, here's the first one, y minus 9 equals 12 quantity x minus 2. And the next one is y plus 7 equals 12 quantity x plus 2. Those are the equations of the two lines.